Hey guys, let's get this over with. Let me fix this. Why is it zoomed out? I don't know. The variable w varies jointly to x as x to the power a, y to the power b, and inversely as z to the power c. A, B, and C are positive integers. The units of x are in oingos. The units of y are in oingo-boingos. The units of z are in boingos. And the units of w are in oingos cubed per boingo. If y is equal to 100 when x is equal to 40, y equals 20, z equals 36. Find the sum of all possible values when x is equal to 80, y is equal to 120, and z equals 72. Okay, so I'm assuming we'll probably get two different proportionality constants from a quadratic. That's my guess, but let's see. So we know that 100 is equal to k 40 to the a. Oh, we also know these units. So units of x are in oingos. So, and w is in oingos cubed per boingo is equal to k times oingos to the a. So we have oingos cubed minus a over boingo is equal to k. So it says assume the proportionality constant is unitless. But that doesn't make any sense. Because like this can't be unitless because you can't change the power of boingos here. I don't understand. Boingos cubed per boingo. Yes. Okay, let's look at y. Y is oingo boingos. Oingos cubed per boingo is equal to k oingo boingo to the b. I'm gonna use capital B for boingo. Oh, okay. So now we have oingo to the 3 minus b over boingo to the b plus 1 is equal to k. And then this last one, 0 and boingos. Okay, so we have oingos cubed per boingos equal to k boingos to the c. Oops. K boingos to the c. So now we just have oingos cubed over oingos to the c plus 1. So we need these all to be the same. So oingos to the 3 minus a over boingo is equal to oingo to the 3 minus b over boingo to the b plus 1. And oingo to the 3 over boingo to the b plus 1. See, we can't alter the maybe oingos and boingos aren't independent. Because then if we just did this, then that'd mean that both this is going to be C. This is going to say A has to equal A, B, and C all equal 0. Using this, but I don't think this is true. Because I think oingo is equal to Q is a constant boingo. That's my theory. So then that would mean we have q cubed Oingo squared here. Q cubed Oingo squared is equal to k q a Oingo a. So then divide, so q to the 3 minus a Boingo to the 2 minus a is equal to k. So then a has to equal 2 to make this true. Because this has to be unitless, so we can't have Boingos, so this must be 1, so a must be 2. So q to the 1 is equal to k. So now we can just, for here we have, it's going to be the same thing. Q cubed Boingo squared is equal to k. And then Oingo Boingo, so it's going to be it's I'll use Q. Why not? Q Boingo squared to the b. So it's a q cubed Boingo squared. I'm gonna use k now. So what we're trying to solve for is b is equal to k times k to the b Boingo to the 2b. So it's k to the b minus 1, so we have k to the 3 minus b plus 1. No, that's b plus 1, so we're gonna have... Wait, what? This is gonna be k to the b plus 1, subtract from both sides, minus b minus 1, and then we have b to the 2 minus 2b is equal to 1. So we need 2 minus 2b equals 0, b is equal to 1, which means that this is 3 minus 1 is 2 minus 1 is 1, so k to the 1 equals... What? We just got k is equal to 1. Okay, if k is equal to 1, then that makes this easier, I guess. So did we get a yet? A is equal to 2, b is equal to 1, c is equal to... Okay, so now we just have Boingos. So O to the 3 minus 1, not O to the 3, no. Q to the 3, it's going to be k to the 3. Boingos squared is equal to Boingos to the c times k. Oh, here it is. Oh, no, 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 no. No, 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 no. Did I do this wrong? I don't think so. I think I've been forgetting the inverse condition. That is important. I'm gonna use K2 here just in case, then we can merge it if I see it's fine. B to C. So now we just see, oh, this would imply that C is negative, which is not true. Gosh, everything has been going so well, but no. Shoot, 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 shoot. Then maybe let's revisit this to see if it's possible. Oingo cubes per Boingo, if they're independent, is equal to K times 1 over Boingo to some power. Right? No, that's still not possible. Still not possible. Not possible. Still not possible. 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 We have no oingos there, so what can we do? I feel like there's something here that I can possibly do. If I could just figure it out. Oingo's cube per Boingo is in fact Q cubed Boingo squared, but I still don't have a font, or just the units don't work is what I'm trying to say, and that's confusing me. That's concerning me and confusing me, and I don't know what to do. Maybe let's just look at these equations, because this Oingo Boingo stuff is just not working out for me. I don't know why or how, but, yeah. Maybe let's just entertain the fact that this is negative, even though it says it can't be negative, but maybe that gives us an answer that's correct. I don't know. That these two cancel out, which means 1 cubed is equal to k2, k is equal to 1. So k is just 1 for all of these, so that just gives us 1 value. So I somehow maybe forgot a different case, because I only got 1 possible value for the answer. Wow. So the sum of all possible values of w is just this value. So w is equal to 120. Because that's what y is. This does give us a lot of information with just the numbers alone. Maybe we can get something using just the numbers alone. Think about it. If A, B, and C are positive integers, they can't be that large. Because we're going to be having to do like 1, or at the least 72 to the power of that number. So it can't be like 12. It's going to be like 1 or 2. So given that they are just that small, they do have a proportionality constant which can cancel that out, but and I don't know.
The sum of all possible values, we need to find all the values of W given these conditions. And these conditions are sure that they vary jointly with this. I understand. Can I like make it semi-transparent? I understand this part. I understand this part. Can I somehow?
No, I can't make that transparent. This makes sense. Oh, wrong thing. This makes sense. This makes sense. This I understand, but it's not, it's not what needs to make sense. This, in fact, does not make sense to me. I understand what it's saying, but the numbers just don't work for me.
And given that that's one of the main restrictions, I can't form a complete answer to this because I don't have all of the freaking information. So my guess to this question is gonna be, is this the right size? No. My guess to this question, as I said before, is going to be 120, but if you think about it, that doesn't even work anyways, because I just get, I'd be saying W is equal to 80 squared, W is equal to 120, then W is equal to 72 squared. And all of those give different numbers, and that doesn't make any sense, but I don't know, who cares at this point? Um, Anything else I can do? I understand the units part, maybe you can do it, but I'm just gonna pick the answer. Okay guys, this is why you study the part of math you do before doing a question. Because I just totally didn't understand the question correctly. I didn't get this right, it was like 1500. The question's saying it's w to the, I need to look at this. It's w to the k times x to the a, y to the b, over z to the c. So if it's oing, so this is where we get it. If it's oingos cubed per boingo, we have oingos cubed per boingo is equal to oingos to the a, boingos to the oingos, boingos to the oingos, boingos to the b over boingos to the c, boingos to the c. So we're saying that 3 for oingos cubed is equal to a minus b, and 1 for boingo is equal to b minus c. So we have these two numbers here. We can't solve this, of course, because there's 3 variables, 2 expressions, or 2 equations. But I mean, yeah, that's the best we could do with that. But now I actually understand what it's trying to say. We could simplify it to can I? But it's saying boingo is equal to 1 plus c. I mean, yeah, I can get an equation with all of the, I can manipulate them. You can't just get boingos even. I don't think so. Yeah. Um, but now I actually understand what I was trying to say. So now we say 100 is equal to k times 40 to the a, 20 to the b, over 72 to the c. These are all integers, so we can manipulate this with, I don't know, like factors and stuff, probably. Probably you could say this is equal to 2 to the 2 times 5 to the 2 is equal to k times 40 to the a, 20 to the b, over 72 to the c. Let's take out the factors here, so this is going to be 2 cubed, 2 3a, 5a, and this is going to be 2 2b, 5b, over 72 is 8 times 9 is 3 cubed times 3 2, or 2 cubed, 2 to the 3c, 3 to the 2c. And now we say, oh, but this includes k now, but we do get a ton more equations. We say that using the powers for 2, 2 is equal to, frick. What do we do with k? Let's just say k2 is the power of the number factors of 2 and k. So 2 is equal to k2 plus 3a plus 2b. No, yes. Minus 3c. Ooh, I bet we can, now I bet we can use these equations over here to get the factors of k, the k2. Oh, and then we know k3. Okay, so 0 is equal to k3 minus 2c. Oh, we don't know c. So k3 is equal to 2c. Like, we don't know anything about c. I mean, we know, like, b, but, like, bro. So now we have 3a, 2b, and 3c. We have a minus b, b minus c. We can do 3a, well, 2b minus 2c, so it's going to be, this is going to be 2 minus c plus 3a, 2 is equal to k2, plus these two cancel out. So 0 is equal to k2 plus 3a minus c. Now we need to relate a and c, put this in for b. We get, subtract, we get a, or 3, is equal to a minus 1 minus c. 4 is equal to a minus c. So we get, just 1, 4, so, k2 is equal to 4 minus a. Right? Because then we get, here we get, oh no, not minus a, minus 2a. Because then we get, 2a plus k2, or negative k2, is equal to 2a plus, 4. Negative, or no, k2 is yeah, negative k2 is equal to 2a plus 4. Negative k2 is equal to 2a plus 4. So negative 4 minus 2a. Okay. Now for fives, we have 2 is equal to k5 plus a plus b. A minus b, so we could simplify to a. So we have 3 plus b is equal to a. No, we have 3 plus a. Subtract a from both sides. We have 3 minus a. We have a minus 3 is equal to b. A minus 3. So 5 is equal to k. 5 plus 2a. So 2a or k5. 5. 2a minus 5. Okay, so we have these three equations now, but then again they use new variables. Yeah, this is so hard to read. They use new variables, so I don't even know how to do this from that. Oh, maybe I'd use the numbers? No, I couldn't. Oh, but it is a sum of all possible values, so I could probably do something from there. Maybe? Is anything bounded by anything? I don't really know. I already got the problem wrong. Thank you guys for watching. I'll see you guys tomorrow. Bye.